What you're looking at is the true configuration of the solar system, of our solar system. We've all been raised to believe that it's configured a particular way according to heliocentrism. But what if this is not the case? We know that we've been deceived about many things in recent times, and perhaps it's time to look at perhaps the mother of all deceptions. And in this video, we're going to discuss an alternative model called the TYCHOS, and a new book written by Simon Shack, a second edition of his book, The TYCHOS, Our Geoaxial Binary System. My name's Nigel Howitt of lawfulrebel.com. And in this video, it's a great pleasure to be joined by Simon Shack, the creator of this TYCHOS model and the author of the book, and indeed Patrick Holmquist, the IT specialist from Sweden, who has created the 3D simulation at which we are currently looking. So Simon and Patrick, thank you very much for joining me, gentlemen, and welcome to this presentation.
Thank you very much, Nigel.
Thank you, Nigel. As always, a pleasure to be here and talk about these very interesting matters.
Indeed.
Yeah.
Patrick, maybe you can start us off with a few words about how modern science really seems to be deceiving us in so many different areas. And, you know, astronomy is just another one of these, arguably the mother of all these deceptions, because if we don't even know the configuration of our own solar system, then what do we know, and how could we consider ourselves an advanced civilization? What's your impression of the current state of modern science, Patrick?
Well, it's pretty bleak, to be frank, because and I think this has been a problem throughout the ages in human civilization. Or you have a ruling class, or whatever you should call them, and they want to be the authority as to what is true. And the thing with science is that ultimately the authority of science and what is true is should always be rooted in what we can observe and experiment on, what we can confirm. I mean, that's the scientific method. But the problem we have in science is that what calls itself science today isn't actually science, because it doesn't follow this scientific method. And we can see several examples of this, but perhaps the most, I would argue, the most important thing or field to understand regarding this is actually astronomy and physics. Of course, medicine is a very important area, because it literally has to do with life or death. I mean, if we have a wrong impression of how medicine works, we will endanger our health.
Mm.
But when we come to astronomy and physics, it's also extremely important, because if we don't have a proper science within that field, we won't understand what is reasonably true and reasonably false.
Indeed.
Yeah.
And I mean, for those of you viewing this beautiful graphic of our solar system moving in its perfect geometry and precision, I must point out that the Earth is rotating. This is the Tychosium we're looking at, Patrick's simulation, and the Earth is rotating at a time frame of 1 second per day. So lest anybody concludes that we're proposing that the Earth goes around that quickly, let's just head that one off. But so this video is all about Simon Shack's new book. So maybe we can just, if you could end your screen share for a moment, Patrick, I'm going to show the book and maybe we can hand over to Simon to tell us a little bit about it. Here is the hardcover version of the TYCHOS second edition, and representing 10 years of hard work and research from you, Simon Shack. So Simon, please introduce yourself and do tell us a little bit about this this new edition of the book.
Yes, Nigel, I'd be glad to. So I will probably have to share my screen, and I will go through a cursory review of the book. Of course, the book is 320 page long, so it's unrealistic to tell you much about it. But I have done a few points. I've taken a few points which I want to show you in order to discuss it at least, and to see what it's all about.
Feel free to go ahead and screen share.
So I'll share my screen now. And let's see, this has to go. Right. So here we are. This is the first page of the book. And why do I have a snail here? Well, that's because the Earth is moving at snail pace. It's moving at 1.6 kilometers an hour, which is just about 1 mile per hour. And we will see why that is. So I'll jump forwards to this page and show you, this is the heliocentric model that we all know. We have all been taught this at school, and it's the sun in the middle, all the planets going around in a carousel around the sun, and it's very nice, very beautiful. And it's the success of this model is probably because it's very simple. Everyone goes around in circles, or in elliptical circles, according to Kepler, around the sun. So of course we have been taught this, and we have embraced this because it's very elegant and nice. But it presents problems, geometrical problems, which simply don't match with observation. And that might sound strange to many people, but it can be proven that it doesn't work geometrically or perspectively, or whatever you want to call it. Anyway, this is the heliocentric model. We all know it. We have the Earth in the third lane. We have first we have Mercury, and we have Venus, and then third lane Earth, fourth lane Mars. Okay, so Mars is supposedly in the fourth lane, and Jupiter and Saturn out here. But the thing is that Tycho Brahe, the great Danish astronomer of the 16th century, had come to a different conclusion, quite different. And he had, this is to the right here, we have Tycho Brahe's model, this black drawing. This is Tycho Brahe's model. Tycho Brahe, after the whole lifetime of observation, and he made the most accurate tables ever made, together with Longomontanus, his trusty assistant. They came to the conclusion that the Earth and Mars, the orbits of Earth and Mars, were intersecting.
You mean the Sun and Mars?
Oh, sorry. I meant the Sun and Mars. Thank you. The orbits of the Sun and Mars, this is the Sun, the yellow one. The red one is Mars. They are intersecting. And they had Earth here. But they said that Earth was immobile. It didn't move at all, which we will see later on. I mean, it is not a logical conclusion to say that anybody in the sky is immobile, because everybody in the sky moves. Everybody in the sky has an orbit. All stars have local orbits. But what was the problem of these two extremely good astronomers? They didn't know what this was. They couldn't recognize it as anything that they had seen before. This intersecting pair of orbits is what we now know as a binary system. And in the later years, it has been discovered that almost all of the stars are binary. So that means that any star you see in the sky has a companion. And in this case, Mars is the companion. Well, what do we have here on the left? On the left, we have the exact same system which Patani-Samantha concluded to be the right system of our inner solar system. Patani-Samantha is still regarded as the greatest naked eye astronomer of India. There is a statue of him in India. He's very highly regarded, but nobody knows about him because this has been discarded, this idea. But it's remarkable to see that they came to the same conclusion. Patani-Samantha, the greatest observer of the skies in India, he came to the same conclusion as Tycho Brahe. So now we will jump forward to Tycho's model, which has one new feature. This is a Tycho's model which I have devised. And as you can see, it's the same as Tycho Brahe's and Patani-Samantha's, only that now Earth has an orbit. This is the orbit of Earth, and it goes clockwise. It goes in the other direction of all the other planets and the sun. And we shall explain that later. This is because the whole system slowly rotates clockwise, while everybody else is rotating counterclockwise. But anyway, what we see here is the Earth and its moon, and the blue circle here is what I've called the PVP orbits. The name PVP that I gave to this orbit is because we are now under Polaris. Our North Pole is pointing towards Polaris, a star above us, up here, okay? And what every astronomer agrees upon is that in about 12,000 years, we will be under Vega, which is a star around here. So we will, in 12,000 years, we will come here and we will be under star Vega. And this is generally accepted that this will happen. But the heliocentric theory says that this will happen because the Earth wobbles. And this wobble has been disproven in later years. So instead of the wobble, we have the physical motion of Earth explaining this and explaining the precession of the equinoxes. Because we know that it lasts for about 25,000 years. And I've come to a more precise figure value of 25,344. And that is explained in the book. So this is what the Earth does in 25,000 years. We move very, very slowly. We move just this little much. If you see my mouse, we've moved just this in the last 2,000 years, this much. So every 2,000 years, we change zodiacal sign. And that is, every astrologer knows that every 2,000 years, we change, we go from one astrological sign to the other. So now we will, about our Sun-Mars binary system. This is chapter 3 in the book. So we see the sun and its two moons. Why do I call them moons? I call Venus and Mercury moons because they are obviously the moons of the sun, because they always when they face us, when they come facing us, they show the same face to us, just like the moon. Both Mercury and Venus do that. And that's...
You mean they're tidally locked, yeah, to the sun? Yeah.
They're tidally locked to the sun, but when Venus comes close, this is a mystery for modern astronomy. Why does Venus show the same face to us? That's a mystery for astronomers to solve, says NASA. Even on the NASA pages, you can read, we still need to solve this mystery. Is it a coincidence? No, it's not a coincidence. It's because it's the moon of the sun, and so it will show the same face to us. So now Mars, I don't know how many people know that Mars has two moons as well. Mars has Phobos and Deimos. Mars has two moons. So you can see how harmonic this duo is, this couple of bodies are. They both have two moons, and they revolve like this, as you saw on the TYCHOS simulator. But I will have to go forward because we have little time. And so what is this on the left here? This is a classic diagram of a classic binary system. Every astronomer knows about this. The thing is that if you go searching on Wikipedia, how many stars are binary, they will tell you 50%, but that's not true anymore. In the 1980s, the top expert of binary stars, Wolf Heinz, a German, concluded that at least 85% of the stars are double or binary. They have a companion like this. This is a star. This is any star you can see in the sky, but it will always have a companion. Okay, and they revolve in intersecting orbits around their common center of mass, common barrier center. So at the start of my research 10 years ago, I conjectured this, well, why not? Why wouldn't the sun also be have a companion? So Mars would be the companion. The sun has two moons, and Mars has two moons, as I just said before, and the Earth will be here in the middle, maybe in the barrier center. We'll see about that later. But you could call it, like here in this at that 10 years ago, I would say, yeah, that's probably the barrier center, and it still may be, but more study is needed to determine exactly that. So now we jump forward to, okay, what is this? To the right here, this is a drawing that Johannes Kepler made in his Astronomia Nova, his opus magnum book, the most famous book he ever wrote. And in the first pages of his book, he shows this hypothesis of how Mars goes around us, or goes around in the sky. He came to this conclusion, but he discarded it because he couldn't make any sense of it. But this is what he drew. So when we got the TYCHOS working, the simulator that Patrick has made, with the data I have given him through my research, this is what the TYCHOS shows. It's a photocopy. It's exactly what Kepler drew. And this is from 1580 to 1596. It's 16 years on Mars. And here you can see it's very small, but that's what Kepler was wrote here, 1580 to 1596. I've just made the TYCHOS rotate for 16 years here, and it comes to completely, it's a photocopy of Kepler's drawing. And note that Mars has retrograde motions which can be larger or smaller, and he also came to that conclusion. See here, they can be smaller. These are the retrograde motions of Mars. When Mars starts going, everyone knows, every astronomer knows that all our planets periodically stop and go backwards for a few weeks or months.
As observed from Earth, yeah.
That's observed from Earth. And this is here perfectly explained why some are smaller and why some larger also. And we'll get to that later. So now we jump fast forward to chapter 6, where I talk about Sirius. Sirius is the brightest star in our sky. Okay, we all know Sirius. Everyone who has looked any time in the sky knows that Sirius is the absolutely largest sky as we see it from Earth. And it is extremely important for the TYCHOS model to the study of Sirius. Why? Because Sirius A, this is not my graphic. This is taken from an old astronomy book. Well, not that old, because they only discovered this 100 years ago, or 150 years ago, that Sirius has a companion called Sirius B. Sirius B does this large orbit, and Sirius A, which is a big star, does this smaller orbit. Okay, this is Sirius A. And Sirius B does these longer orbits, and they intersect each other. And this is how it's observed to move down in the sky, but let's leave that for another time. What is important here is that Sirius A and Sirius B have these two orbits. Okay, so I take this old drawing and I compare it to the TYCHOS. Well, now I have added here, it's Sirius C. I've added Sirius C here. It's not in this drawing because they are still not sure if Sirius C exists, but there are many studies that are pretty sure that it should exist, but they can't see it with the telescopes because it's blinded by the glare of the big star. So if Sirius C exists and we hypothetically place it here, this will be I mean, we see that we are a twin of the Sirius system, because Sirius C would be the twin of Earth, Mars would be the twin of Sirius B, and the Sun would be the twin of Sirius A. And now, I mean, get this. At some stage in my research, I wondered how big are these two proportionally. Well, Sirius A is 205 times bigger than Sirius B, and the Sun is 205 times bigger than Mars.
Amazing.
Correct? So that no one has, I mean, that was my own discovery, but it wasn't a discovery. I just read the data that we have. But nobody has pointed this out yet. Still today, no one has ever pointed out that they are proportionally identical. Sun and Mars are proportionally identical to Sirius A and Sirius B. But even more incredible, it's that in this configuration that I have conjectured, if you like, well, Sirius B arrives at a perigee, which means the closest passage to the central planet here, Sirius C, of 1, and an apogee of 7. It's a 1-to-7 ratio, exactly like we know that Mars does, 1-to-7. So even the proportion of the orbits is identical in these two systems. So this is why I've dwelled a bit on Sirius. Well, I've dwelled a lot on Sirius in this book, but we can't look at it all now. We have to go forward. And so we go to this very important chapter which is called "The Copernican Model is Geometrically Impossible." And I have dared to call it impossible. Impossible is a word that irks many people, but it is impossible. Why is it impossible? Well, because Mars, this is, now we are looking at a heliocentric simulator. This is not a TYCHOS. This is the scope simulator, which is heliocentric, and the conventional with the sun in the middle. And on this date, 5 November 2018, we had Earth here, Mars here, and a star called Deneb-Algedi here. Well, 546 days later, which is 1.5 years, which means we would have gone 1.5 times around to the sun. We would be here, of course.
According to the heliocentric model, yeah.
According to the heliocentric model. And Mars appears here. But in reality, on this date, 4 May 2020, we saw the star Denebel JD aligned with Mars again. Although the two of us, Earth and Mars, had moved by 300 million kilometers sideways, but we still saw that star again, just aligned with Mars. Okay, so what do Copernican astronomers say about this? Oh, well, that's because the star is so very far away. So they're 300 million kilometers is nothing. It doesn't do any, we can't even notice that because the star is so far away. Well, in any case, these two lines on that simulator, which is quite precise, and I mean, I measured the pixels. They're totally parallel. They're exactly parallel. So haven't you learned in school that two parallel lines never conjoin? No, well, they will say that maybe they're not exactly parallel. That's why, and so on. They have to, explain this away in a very strange manner, and it doesn't make sense, simply. Here is another type of simulator, the Neve planetarium, which confirms that the star Denebel JD was very close to Mars here and here on these 2 days that I chose. Now you will ask, what happens in the Tychosium then? What does the TYCHOS show? Well, this is what happens in the Tychosium on these 2 dates. Mars will be here first, and then 546 days later, it will be here, still on the same line pointing to that star.
Seems more credible, doesn't it?
It is exactly on the same line of sight, instead of this craziness here, 300 million kilometers. Okay. But so did they do a more, a more complete check of this? Yes. So what I discovered at one stage was that the Maya people knew that the Mars has actually 2 periods in which it returns facing a given star, and these periods are 707 days. 707 twice, 707 thrice, 707 4 times, 7 times 707 days, but the 8th time, it realigns with that same star in only 546 days. How could this possibly happen in the Copernican system? Well, we just saw that they say that, yeah, of course it happens because that's what's observed. But how can that be geometrically possible? Well, the Maya people knew about this, but no one has ever really understood why Mars does this. And this is why, because Mars in the TYCHOS does a spirographic motion around us and will close this spirographic pattern earlier the 8th time around. So here is this is a demonstration which everyone can check this out for themselves. They just need to get familiar with the Tychosium simulator, and they will see Mars aligning with a given star in all these 8 dates. And this date here, 546, is exactly on the same line as all the others, which are 707 days apart. So Mars always comes back on the straight line. So anyone who wants to say that the Tychosium shows this just by coincidence has a lot of explaining to do. The Tychosium proves that Mars moves in this way, and there is no other competing model that can show this. That's why I'm so sure of the exactitude and that the Tychos model is the only possible system.
Yeah, it seems to me an accumulation of evidence, isn't it? Because I mean, it's difficult to say that this proves it, but when we look at the sum of evidence that you show us, it's extremely compelling when you put it all together.
Yes. Well, okay. So where was I? Oh, no, I went back here. I probably have to go.
Maybe we could just discuss a few of the points that you've made by way of a summary.
Yeah.
And Patrick, maybe you could come in and comment too.
Yeah.
Essentially, to summarize there, correct me if I'm wrong, of course, Simon, please interject if I say anything incorrectly. But your Tycho's model picks up the ball where the very famous astronomer Tycho Brahe left off. He was perhaps constrained politically with his idea of the Earth being fixed and stationary in the middle due to the predominance of the Catholic Church and all that sort of thing. But you've added in this crucial part, the PVP orbit, which in itself adequately explains the precession of the equinoxes as the Earth moves around its own orbit, its own circle, and we see the firmament actually move and change over that 25,344 year period. And you've also offered as a major part of the puzzle the fact that almost every observable star has been now shown to be a binary pair, and this is what Tycho Brahe had shown, inadvertently, not knowing that all these other stars were, because he didn't have a telescope powerful enough. And you've shown that, why would the Earth and why would the Sun and Mars be different? And in fact, Tycho Brahe's model shows that that you've shown us the analogy with Sirius, A and B, and indeed all of the other binary pairs. Did you want to add something to that, Patrick, by way of summary or comment on what we've discussed so far, or what Simon has shown us so far?
Well, what I could do, Nigel, to help the listeners, or rather the viewers, is to fire up Tychosium and show what we mean. Yeah. So I'll share my screen here. So what we're seeing here, I'm just gonna help if anyone interested in this. If you go to TYCHOS.space, you will find a link to where you can buy the book, and then you will find a link to where you can run the Tychosium. So here's where we started Tychosium, and when we started Tychosium, which is the simulator for the TYCHOS system, we get this picture. And it's 3D, so just by holding the mouse and moving the pointer, we can see the system from all angles. And then if we press run over here in the control bar, the system starts, the simulation starts, and here we have the current date and the time, and also Julian day, which is an astronomical term. And here we have a speed setting, and now the model is set at 1 second equals 1 week. So every time a second passes, the model moves 1 week. So we can see we have a rather high rotation speed on Earth, for example, over here. But I think this is very enlightening to when anyone who starts to wrap their head around TYCHOS and actually understand what it means. Because as you can see here, the sun is moving around the Earth. And while the sun is moving around the Earth, the other planets, Mercury, Venus, Mars, but as Simon pointed out, it's much more reasonable to call Mercury and Venus moons. But the other planets, they are orbiting the sun while the sun is orbiting the Earth. That is very crucial to understand, because that is what, in essence, creates the retrogrades that Simon mentioned, and that all astronomers know about. So, and we can illustrate this. We have this function called trace, where the planets will show a trail, and by default we only see a trail for Mars. But if we go here under this section of the menu, we can add some other planets. We can, for example, add Jupiter and Saturn, because they do observable retrogrades as well. And I think this is so explanatory, because if we understand this, that the planets are orbiting the sun while the sun is orbiting the Earth, we understand why the planets do retrogrades, because that's been a mystery in astronomy for all times. Why? And now we have some what shall we call it, an optical explanation for it in heliocentrism, but that explanation is geometrically disprovable. It doesn't work. And before that, Ptolemy and Aristotle, they used what's called epicycles to explain this. They had imaginary spheres, extra spheres for the planets, so that would allow them to move backwards in a model. But the neat and fantastic thing with a Tychonic model is that they aren't required, because in this configuration the retrogrades is very natural.
Absolutely. And it seems so counterintuitive to think that other planets might rotate around the sun while the sun rotates around the Earth. But you're showing us graphically beautifully that this actually explains what we observe, which is very powerful and compelling.
Yeah. So that's one thing. So I really encourage anyone who is interested in this to find your way around the Tychosium and just run it. Do whatever if you get stuck or lost, you just do a refresh, and you will start from the beginning. So I just wanted to also show the key thing with the Tychos, because what we see here is the Tychonic model, and that was conceived by Tycho Brahe in the 16th century. But as Simon mentioned here, as what you can see, Earth has an orbit also, and Earth is moving clockwise in its orbit, while the sun and the planets are moving counterclockwise around the Earth, and it's moving very slowly. So we have to do some time jumping here to show. So if I stop the system here, stop the simulation, and then I set the time setting here to that 1 second equals 1,000 years. And then I step forward. We can step, instead of running the simulation, we can also do steps here. So every click will be 1,000 years. And when we do this, you will see the Earth moving in its orbit. So if I go around here, now we have moved 8,000 years into the future. And and eventually Earth will have completed a lap in its orbit. But as Simon mentioned before, this takes quite some time. It takes more than 24,000 years.
25,000 years. 25,344. Yes.
Yeah, more than 24,000 years.
25,344.
Oh, sorry. Yeah. 25,344. Thank you.
Yes, it's exactly that.
Yeah.
As I have been verifying, and okay, and there is even a very much longer period, which is 811,000, which is also explained in the book.
Go on, carry on, Patrick.
Yeah, and I think the beautiful thing with this PVP orbit is that with the Tychonic system with Simon's PVP orbit that he has dubbed the TYCHOS system, all the astronomical problems we have today, and we have them. It's just that they're not so talked about. It's how to explain the precession. The precession isn't actually explainable in the way they try to explain it today, with what's called axial precession, that the Earth supposedly wobbles. because it isn't explainable. That isn't a reasonable explanation for a number of reasons, but I think the most blatant problem is that if the precession is because a movement only the Earth does, then naturally our relation to the objects in the solar system needs to change as well. But they don't. It's only a relation to the stars that change slightly over time in the precession. But as you can see in this model, the entire solar system is following Earth when it moves, because Earth is the center of the system. So all the objects in the solar system remain in the same relation to the Earth. But since the Earth and the entire system is changing in relation to the stars, the precession works. So it's so extremely elegant, and there are a lot of more things that is astronomical problems that is solved with the PVP orbit. We have the analemma, for example, and the fact that every star is moving in a trochoid pattern that is very hard to explain. etc.
I will cover those things in my continuing.
Absolutely. Well, maybe we'll get back to Simon's. May I just interject just to hammer home a point about the precession of the equinoxes? I think it's very beautifully explained by this Tychosian model. If one imagines oneself on a carousel at a fairground, if you're standing on the outside of the carousel, maybe riding one of those horses that goes up and down, and as you look outside, if the carousel was going very, very slowly, analogous to the PVP orbit of the Earth, imagine that you were observing from the Earth the solar system doing what it does according to the Tycho's model, and if the carousel took 25,344 years to do one turn, what you would see the background scene of the fair actually rotate once around in that very, very long period of time.
Yes.
Which is precisely what we see the firmament do over that period of time, which is what the precession of the equinox is to the lay people that don't understand these astronomical terms, perhaps. You're seeing the background stars move around in a huge circle over a phenomenally long time, the 25,344 years. Sorry to interject with that, chaps, but I just thought that was
perfectly summarized.
Shall we go to Simon, or did you want to say some more, Patrick?
No, I think that was a good summary there of the precession, Nigel, and it's I think as I and many, it's good to have a thorough understanding of these astronomical terms.
Maybe you could quickly, Patrick, maybe you could quickly show what the sun does in 25,000 years. You just put the trace in the sun and you show how it
yes, that beautiful pattern.
We can see some beautiful things happening in the, so
you can do it very quickly.
So just to show if anyone wants to repeat this, what I'm doing now is that I'm setting the time to a high setting to 1,000 years. And then I have switch on trace, and then I set trace for the sun, and then I step forward
25 times. 25,000 years. And this, what you're seeing being drawn now, ladies and gentlemen, is something that I drew before I met Patrick. This pattern of the sun I actually calculated with pen and paper, kind of.
Beautiful. Look at that.
And it's a graphic, it's a diagram that I made on my simple graphic editor, calculating with my numbers, which I had available. And it was exactly this. And you can imagine my delight when, after Patrick made this simulator, that it actually drew the exact same thing. So yeah, I'm pretty. Oh, sorry, I'm really proud of that. You know, simple hand. I mean, pen and paper calculation that I made, because that was the base of my theory at the time. But I could only dream of simulating this on a digital simulator like the TYCHOS, and this is what has happened.
Fantastic. It's
Yeah,
amazing.
yeah. I mean, I just want to make clear that the TYCHOS is really a very strong confirmation of the TYCHOS model, the strongest imaginable in my view, because I mean, and just so people understand that this isn't just a toy. I mean, all the actual positions of the celestial object
bodies.
can be found here, and you can compare it with official figures. Well, now we're in year 52,000, so we won't be able to confirm these figures. But if we do a reset and go to today, you can verify this.
Yes, I've been fine tuning. I've been fine tuning
and what I actually, when I met Simon and he showed me his work, and I started reading his book, I was skeptical, to say the least, and I think everyone who looks into this is naturally very, very skeptical in the beginning, because since we began first grade in school, we have learned that, of course, the Earth orbits the Sun. It can't be the other way around. But as a process in my own understanding of this, I wanted to help Simon and do a simulation, and if we could do a simulation of this system, we could show that it works in the way imagined by Simon, then it's confirmed.
Yeah.
And that's been working. And anyone who has anything else to say is very welcome to peer review this work and have a reasonable discussion around it. But that's been very hard, because it is such a dramatic department from our current view of the world. And yeah.
It's a beautiful visual representation, because the movement of the solar system is a conceptual idea, and it's fantastically difficult, and hats off to the astronomers of ancient times, because they managed to conceptualize this in their minds, but we're able to see this graphically represented in 3 dimensions by the TYCHOS, which is a fantastic tool to aid us to conceptualize the motion of our solar system.
Yes.
Do you want to carry on then, Simon? Should we look at a few more points that you raise in the book of the
Yes, I will just add a few things for basic things that we need to understand, that the TYCHOS seems more complicated than the heliocentric system. You remember I started showing the heliocentric system with a beautiful sun in the middle and a nice carousel. It would seem to be more complex because of these spirographic motions, but in fact, it is a much simpler system, because it does away with many things which are not needed. And if you know about the Occam's razor principle, I think everyone agrees that any scientific problem which has less complexity is preferable. And what it does away with is, it does away with the need for accelerating and decelerating speeds of all the planets, because Kepler had to use his mathematics to get to that, because he couldn't make the thing work in a heliocentric way. He had to make the planets accelerate and decelerate, and he had to add an elliptical, little small elliptical shape. And I repeat, very small elliptical shape, just to make the things match. But
Yeah.
this is not necessary. In the Tychosium, all the planets you see in the Tychosium move in circular orbits and at constant speeds. The retrograde motions are explained in the Tychos because, as we saw, even though Mercury always ever goes round in a circular orbit around the sun, it will seem to go backwards from the perspective of Earth, just like a cowboy with his lasso running around us. And the torch here will do this. It will actually physically do this loop. But that doesn't mean it's going backwards. It's just that it's always rotating around the lasso. So this is a try to visualize what's going on here geometrically. Anyway, so we will need to see we need to see the PVP orbit, what it is exactly. The PVP orbit, how did I estimate the PVP orbit's diameter, for instance? Well, what we see here is not my graphic. This is from an official astronomy website showing that we are under Polaris now. Polaris is our North Star, okay? It's been our North Star for the last hundreds of years. But 4,000 years ago, we know that Tuban was our North Star because the Egyptians have left documentations about that. We know that we had Tuban as a North Star 4,200 years ago or so, okay? So astronomers have been able to estimate what kind of circle we are doing. You know, this is looking up in the sky, right? If you're standing on Earth, this circle is a circle that we will do in 25,000 years. So we go from Polaris and then we wait under Vega, almost halfway under Vega, and then we return to Polaris. So this is not my conjecture. This is what all astronomers will agree with. This is from an astronomy website. So what I did was I tried to see, could this be because we are actually moving physically around such a circle? And that's how I started calculating by imagining a virtual orbit of the sun, which was tilted 90 degrees. So this is in an imaginary solar polar orbit. So how long will it take for the sun to move from Polaris to Vega? Given our observations, it would take 44 days, and that would be 113 million kilometers. So, but if we lay it horizontally, here we can see it's 44 days, and that's how I estimated the and I've done a much more complete description of this way of estimating the PVP orbit. This is a PVP orbit here, and here we are today. Here we are 12,000 years from now, and then we go back to here. And we are under Polaris today. We will be under Vega here after 12,000 years. So this is a bit complex to take in, but all these angles are very carefully calculated, and they correspond to what we see. I always follow what has been observed, and there is nothing I've invented here. So now we will go to here to show. This is a very big. This takes up a whole page of the book, and it shows then again. It shows that here we are today. We are looking up at Polaris. Our south star is Sigma Octantis. Everyone can see that with a telescope. So this is exactly how we are. We are angled at 23 degrees, right? The Earth is angled. And this angle, this tilt of Earth always stays the same as we go around the PVP orbit. And then it will be on the other side in 12,000 years. So we will be up looking at Vega. And then we will have a South Star Columba, which is also predicted by official astronomy. But I explain it in a different way. They explain it because they think that Earth is wobbling, but that wobble has been shown to be non-existent. But I think it makes much more sense that we are simply moving physically around this orbit. This is a bit enlarged. This is a PVP orbit. And what do we see here to the left? Well, that's the graphic that we showed on the TYCHOS a while ago. The graphic I made years before meeting Patrick. Here it is. This is what we do. This is Earth tilted by 23 degrees. This is 6,000 years from now. This is 12,000 years from now, 18,000, and then back here. This is what we do. We go around this PVP orbit, and the rest is what the sun does, as we saw on the TYCHOS simulator. So this graphic was made long before it was confirmed by the simulator. I just wanted to show it to you. So we can jump forward. Okay, so here this is very interesting because we are talking about Mars now. What is the role of Mars in our system? Well, the role of Mars appears to be like the pivot of the whole system, because Mars just happens to pass all the time in the middle of the PVP orbit at 56.6 million kilometers. Every astronomer will agree with that. When Mars passes closest to us, it is about 56.6 million kilometers from us. 56.6 million kilometers is exactly half 113.2, which is the diameter I have estimated of the PVP orbit. What a coincidence. That's how things are now. We have Mars passing all around the great here. It will always pass here. You see the green dot? That would be some kind of barycenter of the whole system. This green dot is the barycenter, but it's a secular barycenter. Probably.
What do you mean by secular barycenter, Simon?
Well, the whole system has a secular barycenter because what does the whole system do? It does this turn in 25,000 years. And what is in the middle of this turn? It's the spot where Mars always passes when it gets closest to Earth. So more studies needed here to understand how exactly things move in space. This kind of detail could never have been discovered by looking with telescopes on other systems. They are too far away. We can only know better how these dynamics work looking at our own system. That's my point.
Yeah.
And our own system tells us this. You know, we can't know exactly what Sirius A and Sirius B do because they're far away. We don't know exactly how they move. We can only, imagine, but we have enough data to make this graphic. This is what is this? This is these are 4 screenshots that I have superimposed directly from the TYCHOS simulator, and you have Mars passing always in the middle. All right. So let's go forward. Now here is a very, very, very interesting thing. It's probably a crucial thing to realize that the moon has synodic periods. The actual average synodic period of the moon is 29.22 days. And that's a value, that's a number that the Maya people knew, and even the Egyptians and the Persians, they used this number. But we are told that that number should be 29.5, because that's the number of days that the moon employs to return facing the sun. But over longer periods of time, it would average to 29.22. So now 29.22, let's take it as 1. That's the common denominator. You multiply this by 4 and you get Mercury's synodic periods, 116.88. You multiply it by 20 and you get Venus's synodic periods, exactly 584.4. Then you multiply it by 25. It's Mars's periods, and then by 375. These are whole integer numbers. No decimals needed. 335 Saturn and 150 Jupiter, and all the way up to Pluto. They are all round multiples of the moon's period around the Earth. So we could call the moon the central drive shaft. I would call it the central drive shaft. The moon, for some reason, is the central drive shaft of the whole system. Why would that be in the Copernican system? The moon should be just an appendage going around us. We are on the third lane, and the moon is just one of many moons in the Copernican system. No, it's not one of many moons. It's a very, very central moon. We are in the middle here. And it makes much more sense then that if we are in the middle, that the moon has this characteristic. Okay, but there is much more to read about this in the book. Okay, here is how I show the average calculation of why it's 29.22, not 29.53, because sometimes it's less, sometimes it's more. It's very well, mathematically proven. Okay, so let's go to these we have seen before. So 1, 2, 6. Okay, 181. Okay. No. Oh dear, sorry. I'm dialing badly. So the Tycho's great year is 25,344 years, okay? This is understanding it. This is chapter 19. And this is just showing why we move by one zodiacal sign every 2,000 years or so. Actually, 2,112 years. 2,112 years. 2,112 years ago, we were facing Cancer, okay, constellation Cancer. Today, we are facing Gemini. Now, you have to imagine this is June 21, okay? On June 21, we're facing Gemini today. And in 2,112 years from now, we will be facing Taurus, because we're just simply moving around this orbit. Very simply. We're just moving from here to here, and then we're doing a full turn in 25,000 years. So this explains the precessional equinoxes, the alternation of the pole stars, when these pole stars are changing, everything. So now we are going to look at the so-called analemma, and that's the shape that the sun does over a year. But first, we need to understand what Earth is doing. Earth is moving from left to right here. In 1 year, it will move from March 21 here to March 21 here. So it will be rotating all the time, every 24 hours, but it will also slowly move from left to right. And that will cause a man looking at the sky to move like this in 1 year. An astronomer looking at a given star will see that star doing this trochoidal, because his frame of reference will be this trochoidal loop, and that is only explained by the TYCHOS model, because but anyway, you need to know that this is how stars are actually observed. These 3 loops here is from official astronomy websites showing a 3-year periods of star Vega. Star Vega is observed to do 1 year like this, 1 year like this, 1 year like this. That's what is observed. Well, that's because the guy who films Vega will have on his photographic plates 3 loops like this, because he himself is moving like this. As you can see here, I've done a little cartoon here with the astronomer, Jim the astronomer. From 2000 to 2001 to 2002, he will do this physically. He will actually move like this. And therefore, if he looks at the star will show this pattern. And this is what our closest star, the pattern that the closest star does every year, ding, 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 this green pattern. But NASA tells us the looping action is the result of the Earth's motion around the sun. What do they mean by that? Would this be the result of us moving around the sun? No, it doesn't make sense. This makes sense. This makes sense because we are actually, any observer on Earth will do this. I call it the Man's-Yearly path. Okay, so now we go to the analemma, which I said before. The analemma is something that was depicted on all the globes, the old globes. You remember the globes we had in the living rooms? Well, it's an 8. It's an 8-shaped thing, okay? This is how the sun moves. If you take a picture of it every day for a whole year, you will see the sun doing this. So in June, it will obviously be on top here. That's why we have summer. I mean, we're talking about the northern hemisphere here. So we have summer in June, and we have winter in December, because the sun is much lower in the sky. All right, so that's okay. That's very easy to understand. But why is the sun also moving sideways? And why is this 8 asymmetrical? It's much smaller up here, and it's 3 times larger down here. Well, this is explained perfectly by this motion that we do in the TYCHOS model, 3 to 1. And you can discuss this until the cows come home, but this is actually provable. This is what will happen if we are moving in this way. It is hard to envision now. I'm sure it will take time for everyone to realize, but this explains the analemma. Finally, no one has explained it.
Sorry, may I just interject? I think it's important just for perhaps non-astronomers that when you talk about photographing the sun, you'd be photographing it at, say, noon every day, exactly the same time. And if you do that every single day of the year, your photographic plate will trace out this shape.
Yes, well, many astrophotographers have done these experiments. They don't do it every day of the year. They do it like once every 10 days, but they get this time lapse of the sun, which is an 8-shaped thing. So that's what is observed. So again, the TYCHOS is based on observation. It's nothing, nothing mystical. It's all very rational. So we then go to fast forward. We have to jump many things here. Are the stars much closer than believed? Well, yes, they are, because since they calculate the distance of the stars, assuming that we go around the sun. So they take a picture one day, and then they wait 6 months, and they take another picture of a nearby star, and they estimate the star to be very, very far away, because that's 300 million kilometers. the baseline of this trigonometric thing is 300 million kilometers. But in 6 months, in the TYCHOS model, we only move by 7,018 kilometers. That means the stars are much closer, because all the data they have gathered for the stars is 42,600 times larger than it actually is. And that's explained better in other chapters. But yes, the stars are much closer. The stars, not the planets. The planets are, as they say, because they have been calculated using the diameter of Earth, which is 12,756 kilometers, and that we all agree on that. But they say that the stars are too far away to we can't use the baseline of just the diameter of Earth because it's too small. So we have to use the assumed large orbits of Earth around the sun. So that's why all the calculations for the distances of the star are inflated by 42,000 times. So this can, I'm not completely, saying that exactly 42,063 times, it may be a bit different or so, but they certainly are closer than we believe right now. It's absurd to think they are, we can see with our naked eyes stars that are 1,000 light years away. That's absolutely absurd. So we get to the negative stellar parallax. Well, the negative stellar parallax is that they are observing the stars, many stars that go the other way, the way that they shouldn't go. They should move. There shouldn't be any negative stellar parallax, because if we are going around the sun like this, if we were in a car, we would have the stars always in the right-hand window. So there would never be a star having a negative parallax, right? Well, right, you won't get this right now, but this is what I show in the book, and you need time to understand this problem. There cannot be any negative parallax in a Copernican system. Okay, they cannot. It's unphysical, and astronomers agree it's unphysical. So what do? They find these negative parallaxes, and they are actually 25% of all the measurements, and another 25% are positive, or 29. So why are they 29? 29 positive parallax. Here is the Tychosium. Okay, this is the TYCHOS model. We are moving around slowly around our PVP orbits, and on one side we will have, if we measure a star here nearby star, we will have positive parallax. If we measure a star up here, it will be negative, because we are moving kind of in a straight line. So Joe up here will see negative parallaxes, and Jim down here will record positive parallaxes. It's absolutely to be expected in the TYCHOS model. And what about this? 23% zero parallax and 23 assumed zero parallaxes, which is what they say they have. Like 50% almost of all the stars have no parallax at all. That's because we are here and we're going towards that star, and here we're going away from this star. So there will be no parallax. You can't have a parallax if you go, if you look at the tree in front of you're going in the car, you have a tree in front of you and the forest behind. That tree won't move. If you're going towards that tree, it won't have any parallax. You're going towards it, right? If you're going, towards this tree, here is the distant forest. Well, that won't move. And this the same if you look in the backhand window, this won't move either. So this explains what is observed, because these are the percentages, official percentages from the big catalog of ESA, the European Space Agency, called, funnily enough, the Tycho catalog, where they call it Tycho catalog.
I like that.
And they have like 2 million stars data of parallaxes of stars, and they are divided in this percentage. So what do they say about this problem with the negative parallaxes? Well, they still discuss about it. And as you will see in page 228 of my book, here is a screenshot from ESA itself, where they discuss how to truncate their negative data. They deem them unphysical. You know, they are unphysical. They are impossible. So we have to do something about them. I mean, this is a very funny read. They are trying to, you know, shove them under the rug, the negative parallax. So anyway,
a beautiful example. I think this is very compelling, Simon, if I can just say so. The star parallax issue, for me, again, as a non-astronomer, I'm just a layman coming to this, and the issue of star parallax I find extremely compelling. It just doesn't fit. The available data cannot be fudged into the Copernican model, and it's explained beautifully by the TYCHOS and the PVP orbit.
Yes, it's a kind of, you know, confirmation bias they're going on about. It's an ad hoc reasoning they're going with, and it's completely against any scientific method, as Patrick mentioned earlier.
Yeah, it could be summarized as you showed before, Simon. We have about just as much negative as positive parallax.
Yeah.
And they love the positive parallax because that doesn't disprove the heliocentric model. But then they do all kinds of strange maneuvers to try to ignore the negative parallax that is just as high as the positive parallax.
Yes.
So what is going on?
What is going on? Okay, but we have little time. I think we have a little time left, so I'll just jump very quickly to chapter 30, which is the longest chapter in the book. It had to be long because I had to prove it, you know, methodically that what Halley's Comet does. And the Halley's Comet is extremely interesting. Mind you, Halley's Comet was what made Newton's theory really, you know, established his theory totally. It was deemed as the final demonstration of Newton's theory. Okay, it's not a minor matter. Halley's Comet is a major matter of astronomy. So that's why I really did. I wish to do a complete investigation of this, and it reads like a thriller, guys. It's really, because what happens with so what is it? What do they say that the Halley's Comet does? Well, it's supposed to do cigar-shaped orbits around space. It comes close to us here, and then goes away all the way to Neptune, and then decides to slow down here, and then accelerate and go back to Mama, go back to the sun. Okay, this is what they say that all comets do. All comets should do cigar-shaped, very elongated, super elliptical orbits, very compressed orbits. No other bodies do this. No asteroids, all asteroids go kind of in circles, but no, the comets are special according to them, according to official astronomy. Well, no. What made Newton reach this conclusion of elliptical orbits is explained in this chapter. This is what Halley's Comet does. If you open the TYCHOS, get familiar with it, you will see that this is what it does. It does exactly what the other planets do. It does a trochoidal circular orbit. Now we are seeing it sideways. It's not elliptical. This green thing is what Halley's does in 76 years, 75.7 years exactly. It returns every 75.7 years, very close to Earth. And very close to Earth, not to the sun. It gets much closer to Earth. So why is that? Isn't the sun much bigger attractor than Earth? Well, it comes at 0.1 AU to Earth, but only 0.4 to the sun. That's the first question you have to ask yourselves. But there is much more about Halley's Comet. What is the really funny thing about Halley's Comet? That every time it has appeared in the sky over the centuries, over like the last 200 centuries, there has always been one or two comets coming 1 year before or 1 year later, and they said, no, that can't be Halley's Comet. That can't be, because it moved in the wrong direction and it wasn't where they expected it to be, and so forth, and so on and so forth. But I have shown that all those comets, which were called the Dunlop's comet or Boguslavsky's comet, or all these other comets which they saw 1 year before or 1 year after, were always Halley's Comet. Because since it goes around like this, I mean, let's take an example here. Let's see if I can find an example. Yeah, here. This is how it moved. Here is when Halley's Comet came in 1680. Okay, it was here, and then it was observed here at A. It was observed here at B, and then it make like this, and it was observed here. Well, it was not observed here at C and E, but then it was observed here. But anyway, so they have been confused completely about what it does, how it goes around us. And the reason why Newton decided it was doing a U-turn around us, and thus doing a cigar-shaped orbit, is explained by the fact that when it was first observed in 1680, there was a comet called the Great 1680 Comet. Eros, the asteroid Eros, which was discovered much later, was in the place what is observed and was mistaken to be Halley's Comet, and then it went around the Earth. Well, I mean, this is too complicated to explain here. I don't have the time, but you need to read this chapter, and just if you can read this chapter, that's all I'm going to say now. If you can read this whole chapter and tell me that all these comments that I have pointed out were always Halley's Comet, if that's all coincidence, then you're a coincidence theorist. You're not a serious scientist. You're a coincidence theorist. This last chapter is the last nail in the coffin, really.
Maybe we can do a video on Halley's Comet on its own, Simon, because as you say, it is a
long story. It's a long story, but it's absolutely fascinating.
Yeah.
And I really wish people to, if they are only going to read one part of my book, it has to be chapter 30. Or, and I finished now, I'm finished, or if they only want to read one part of the book, chapter 31, because here I have 41 enigmas solved by the TYCHOS. I have listed in this last chapter 41 points which are resolved by the TYCHOS. 41 mysteries, 41 enigmas, 41 things that every honest and earnest astronomer will admit that they have. So it's not like astronomers are sure about everything. That's, we are told that astronomy has now arrived at an incredible level of precision. That's just not true.
Yeah.
That's the lie. They have so many problems, and they are in crisis now, especially when you look at faraway galaxies. I mean, Einstein and Newton's theories are completely conflicting, and they can't understand why. For instance, they can't understand why objects move so fast around distant stars.
Yeah.
Well, that's because they think they are so far away. So when they estimate the speed of any object and they think that it's so far away, that speed will look like 100,000 kilometers an hour, or 1,000,000 kilometers an hour, and that is a problem for them. So they have to invent the existence of dark matter. So I will finish off on this. Do you know what Jacobus Captain famously said? Jacobus Captain, who was he? He was the absolute top expert, this man, top in stellar statistics. And he reached this very, very important conclusion. At the end of his career, he reached this conclusion. Here, I will highlight it here. If all stars were binaries, there would be no need to invoke dark matter in the universe. That was his conclusion.
Mm.
So what I'm saying, all stars are binaries. But you want, as I said at the beginning of this talk, many people will say, no, only half of the stars are binary. No, no, no. Wikipedia will say that. No, we are at 90% minimum, more than 90 of stars that have been shown to be double. So I think 100% of the stars are double, and therefore it would be absurd to think that our sun is the only single star in the universe.
Yeah. Patrick, did you have any observations or comments that you wanted to say on you know, some of those last points that Simon's shared with us?
Well, I mean, as Simon mentioned, the Halley's chapter in the book is really interesting, because just as he points out there, I mean, you can take all these passages of Halley's and the so-called unidentified or other comets that came along, or that is always observed during a Halley's passage, and you can correlate them with the suggested orbit that Halley's has in the TYCHOS model. And if you think that is, if you argue that is a coincidence, then it's, I mean, it's one of the many confirmations of the TYCHOS model that it is correct, and it do work.
Yes.
So
yeah, I think that, you know, for anyone approaching this TYCHOS model for the first time, yes, it's a big ask to get people to question an assumption that they've grown up with, that the Earth is going round the sun, and it does take something of a feat of independent thinking and rational thinking, and absolutely rigorous adherence to the facts and to the observable data, as Simon keeps pointing out. He and indeed, Patrick, you mentioned that the TYCHOS is programmed with all of the observable data, and it fits with it. So if one can get over, or if one can, you know, resist the temptation to cling to an idea that we've grown up with, and sort of put it on the shelf, as it were, and try out this alternative model, I think for the rational thinker, for the truth seeker who really is interested in truth, and, you know, we're all interested to know about what false flag terrorism and the climate bogus stuff, and et cetera, there's so many topics that we bust. This is a beautiful one in that all of the observable empirical evidence is accommodated by the TYCHOS model. And as Simon points out there in his last chapter, chapter 31, he lists all of these anomalies, all of these fudges, all of these things that don't quite work with the Copernican model. And it's important to sort of zoom right back and take the evidence in its entirety, because in my experience, it's impossible to point at one thing and say, there, that proves the TYCHOS. I think the proper method, and the, you know, the scientific method, if it were practiced properly, would be to take into account all of the evidence, and there must not be any contradiction. A model has to fit with the observable evidence without any contradictions. So I would, you know, propose that the serious truth seeker give this a serious look, and try to step back, you know, resist our conditioning and look at the facts. And I think the whole case is very, very compelling. I think it's conclusive personally, but yeah, it's a great one. It's beautiful because all of the empirical evidence is accommodated.
Yeah, so one thing that we haven't said in this podcast is that the Tychonic system was accepted for 100 years before the Copernican was accepted. It was actually accepted by the Catholic Church, and no one knows this. I just found this information pretty recently, actually.
On the assumption that the Earth was stationary in the middle, though, wasn't it?
I mean,
that Catholics liked.
Yeah, the Tychonic system was accepted and it was embraced by the Catholic Church, and then it was brought to China, and the Chinese embraced it completely. It works better than any other model, and who knows why the Copernican system finally prevailed, how they got that to work, or to be more compelling, because it had all these problems. And Tycho Brahe himself said that the major problem was the distance of the stars. I mean, the stars just can't be that distant. You wouldn't be able to see them.
Oh, I guess they had one good thing there is one good thing in the Copernican system, and that is a rotating Earth. But there is no support. We can't find any evidence or confirmation that the Earth is actually orbiting the sun. And the ironic thing as well with that is that Longomontanus, Tycho Brahe's disciple, he revised the Tychonic model and added diagonally rotating Earth after Tycho Brahe's death, and that is known as the semi-Tychonic system. So, I mean, we had a model with a Tychonic model with a rotating Earth as well. So,
yes, the semi-Tychonic system is the closest they had, and I've just added one thing, and it's the motion of Earth, which I think is logical.
Yeah. Well, once again, ladies and gentlemen, here is Simon's incredible book, second edition, available in hardback from Lulu. And it's a brilliant read. It's really well illustrated. Simon has shown us there with some of the screen share, some of the graphics. It's very, very well put together piece of work. And indeed, hats off to you, Patrick, for creating the Tychosium, a fantastic means to visualize, to see represented in 3 dimensions Simon's idea, so that this whole conceptual idea of the motion can be beautifully seen in its 3D geometric clockwork precision motion, as we saw at the beginning of this video. So I would recommend, as I said, any serious truth seeker, give this a good look. I consider it the mother of all deceptions, as they used to say at the beginning of Star Trek, space, the final frontier. I think that, as we look out up to the stars and contemplate space, this is the big bit of truth that we need to grasp. I think, everybody, if we don't know how we move in our own solar system, how can we possibly consider ourselves anything approaching an advanced civilization? I mean, it's really elementary stuff. And I would challenge any rational thinker, anyone capable of logical thought, anyone capable of suspending judgment, for the duration of reading the book. It's a very, very, very compelling case. So unless, you guys got any closing words, I think we could leave it there.
Yeah.
That's fine for me. I have no closing words other than saying that, open your mind, and if you can, read the book and then decide for yourselves.
Indeed. Excellent. Well, thank you very much, gentlemen, for joining me on this presentation, and I look forward to seeing you both again. And thank you very much for listening. Do check out the website lawfulrebel.com, and there's loads more on there, and indeed there'll be links to other discussions of the Tychos. And one last final announcement is that Simon, Patrick and myself will be together in the UK, just north of London, this coming summer of 2024, on the date of the 15th, 16th, I think it is, of June, date to be confirmed, but I think that is penciled in as a probable one. You can contact us at the website here, lawfulrebel.com, find out more details, and come and see Simon presenting this model over a 2-day period. And I believe he intends to spend one of those days talking about Halley's Comet. So there you go. Do come and join us in the UK if you can in June of this year. Thanks for listening and thanks for watching.
Thank you.
Thank you.